We'll proceed in innovative approach in calculus and we will see some vector forms. What we have achieved in innovative approach in calculus, what we were trying to see directional derivative along a vector. So we are entering what we do in calculus engineering, what we do in calculus. If we see closely what we do in calculus, then or in mathematics, if I am happy with numerical mathematics, then I do with the numerical mathematics. If I am not able to do with the numerical mathematics, then I go with algebra. Then I go with the algebra. If I am not able to do with algebra, then direct computation, then we use calculus. If we are not able to do with algebra calculus, then simple algebra, then we go with the vector. So if I am not able to do with the vector, then we try with the vector field, algebraic vector, that is hybrid. So we go high till we are able to do the work, and then we come down, and we come at the numeric level back, because at the end people want to see result in the numeric only. So numeric, algebra, calculus, or algebra, we can go with a different coordinate system, and then vector field, go up, try you can tackle the problem. Like directional derivative along any line. Directional derivative, if I have a 3D, if this is x-axis, this is y-axis, this is z-axis, this is 3D, this is a 3D surface. If this is a 3D surface, then what is the, okay, so I have to bring back, okay, so I was talking about 3D surface. So consider this is 3D surface. If this is 3D surface, this is x-axis, this is y-axis, this is z-axis, this is centered at the origin, or it is up the xy plane. This is xy plane. At any moment, what is dz by dx? At any moment, what is dz by dx? The dz by dx is considered as slope at that point. So dz by dx, more or less, we can think as a tangent. Dz by dx. Here, dz by dx is infinite. And you see vertical. Here dz by dx is 0. Means this is xz plane, this is yz plane. In xz plane, if I move along x keeping y constant, I am not saying y equal to 0, any y constant, that is xz plane. In xz plane at y equal to 0, at xz plane y equal to 1, 2, 3, 4, y equal to k. Similarly, yz plane when x equal to 0, yz plane when x equal to k. So xz plane, anywhere at any y, if I cut it, then it becomes a circle. Okay, or if I take like this in xz plane, if I move along x-axis, how much dz by dx I see? If I move along y-axis, how much dz by dy I see? In yz plane, how much dz by dy I see? Now question is arising that dz by dx I know that is the change in z along x-axis, change in z along y-axis, change in z along x-axis, that is in algebra. If I say change in z along this axis, that is x-axis, that is y line equation of x-axis is y equal to 0. Dz by x equal to 0 or x equal to constant. What about if this is x-axis, then this is any axis. This is x-axis, this is y-axis, they are 90 degrees to each other. This is any arbitrary axis. If this is any arbitrary axis, it has a line equation. Line equation is x minus y equal to 0. Now, along this line, if I pierce it, inside this, if I pierce this line, this is x-axis, this is any line, this is y-axis. Now, any line, I pierce it inside it, or consider this is on top of xy plane. This is x-axis, this is y-axis, this is xy plane. X-axis, any line, any line. Now, in any line, what is this? If this line equation is L, this line equation is called x-axis. This line equation is called y-axis. This line equation is called alpha axis. What is dz by d alpha? Dz by d alpha. Dz by dx is nothing but dz by dy equal to 0 line. Dz by dy is nothing but dz by x equal to 0 line. What is dz by d alpha? If this line is represented as alpha line, x line, y line, alpha line, what is dz by d alpha? If that is the case, then dz by d alpha line, then alpha line is nothing but x minus y equal to 0. This is my concept. What is dz by x minus y equal to 0 line? Dz by dx, I know dz by dy equal to 0. Dz by dy, I know dz by dx equal to 0. What is dz by d alpha line? What is the equation of your d alpha line? X minus y equal to 0. What is dz by dx minus y equal to 0? No one can compute this, not possible. Then we go into vector, rising up. Okay, if I am not able to calculate change in vertical with a change in horizontal in numeric, we go with algebra. If I am not able to do, then we take help of calculus. Still we are not able to do, then this algebra we change it to vector, higher. Okay, one layer higher, change into vector, and now try to see. So if I am saying dz by dx, that is nothing but dz by I vector. I is a unit vector along x-axis. Dz by dy means dz by dj vector. Z is height or fxy, function over x and y. Dz by this alpha line is dz by x minus y equal to 0 is nothing but dz by a unit vector along this line. What is this vector representation of this line? X minus y equal to 0, vector representation is I plus j, I plus j. Anyone could try. I have I have talked about it in the past video, how to convert a line into vector form. So I plus j is the vector of this line. So unit vector is I plus j by divided by a square root of 2. So what we are trying to say is if I want dz by alpha line, dz by x minus y equal to 0 line, we are trying to say dz by dz by d I plus j divided by square root of 2. Okay, dz by dx is dz by di vector, dz by dj vector, dz by di plus j divided by a square root of 2 vector. That is directional derivative along this axis. If I want derivative along this axis in modern terminology, if I say, then if I take any point on this line, if I take any point, oh, if I take any point on this line, if I take any point on this line, then one point on this line is u alpha. Okay, this is alpha axis. I take any point u here, then at u, what is the z value? At u, this is x, this is y. I take any point x comma y, I just go up and hit it. Okay, so okay, this is xy plane. On top of it, this sphere is there. If I take any x comma point and go up, it will hit one point. Someone would say it is hitting 2 points, one point here and one point here on the surface. Not really. Actually, this is centered at the origin. If it is centered at the origin, so xy plane is coming at the center. If I take any x comma y, if I take far away from the radius, then it will not hit anything. But if I take any x, it will hit on this. Okay, or in negative direction, it will hit like this. Because z equal to square root of a square minus x square minus y square as far as sphere is concerned. In that case, that is plus minus value will come. Plus will go hit up and minus will go hit down. Now if I do any offset on z, it will come up on the xy plane. That's it. So otherwise, one will hit up and one will hit down. Z has two values for any x and y. I shifted up. Now this is what we are seeing. So at any x comma y, I have a z value. Now consider that we are trying to get the directional derivative along any point u, any axis alpha or any axis u. Name of the so I'm sorry, the name of the axis is alpha. If I am representing it as vector, then it is u. Okay, this name of the axis is x-axis. If I represent it as vector, it is I. Y-axis j. This is alpha. Line equation is alpha, where vector representation is called u. If I say u is a unit vector, then if this is the alpha, line is alpha, then u equal to I plus j divided by square root of 2. Let's take any point u on this, any point u1 or u. Then on top of u, what is the z value? It will go and hit the very heavy sphere. Okay, at u plus delta u, where what is the z value? What is change in z value if there is a delta u change? U and u plus delta u. U I can represent it as x comma y. Delta u I can represent it as x plus delta x comma y plus delta y, because it is changing in both directions, because this is a curved line. So if I move along this line, then x will change, y will change, both. So in that case, what we are trying to get, then what is the difference in, from here there is a z value, here there is a z value. What is change in z when there is a delta u change? dz by du vector, dz by du vector, or dz by du, delta u, or delta z by delta u, where delta u tends to 0 in modern mathematics, or fx plus delta x comma y plus delta y minus fxy divided by delta u, where xy is the point at u. This is directional derivative. What we are saying is, what we gave for the directional derivative is, now consider this is a sphere, then take a particular height in the sphere, like height is 1, height is 4, cut it. If you cut it, then on xy plane directly it can be drawn. If I take a contour, this is called contour diagram. If I take xy plane, if I cut at height 1, cut at height 1, okay, then I can draw a contour diagram. So now for simplicity, now don't consider it is a sphere, it is a paraboloid. So paraboloid equation is simple. Z equal to x square plus y square. Whereas for a sphere, z is equal to square root of a square minus x square minus y square. Someone can map it. So paraboloid is z equal to x square plus y square. If z is 1, then 1 equal to x square plus y square. This is a circle on the xy plane. X square plus y square equal to 1. Or if I z is 4, then x square plus y square equal to 4. That is circle of radius 2. Now, if this is xy plane, this is x-axis, this is y-axis. In that sense, I have a circle centered at the origin, and its radius is 1. Its radius is 1. Now, if I for making it radius of 2, I make it bigger, and it become a circle of radius 2. Then if you see closely, now I am sitting at x-axis. Now this is x-axis considered, and this is y-axis. Now this is the contour I am drawing for the radius equal to 1. Okay, centered at the origin. Now from x-axis I am seeing it growing like this. Then if I see closely from x-axis, whatever I am seeing, that is perpendicular to, this is the direction in which I am seeing the contour growing. From y-axis also I am seeing the contour growing, but from this direction. That is, this is the direction in which I am seeing from the y-axis. Now question is arising, this is x-axis, this is y-axis, where I am seeing the contour is growing. What about if I stand on this axis and how I see contour growing? That is the directional derivative. This is our proof. dz by dx is the directional derivative of z along x-axis. dz by dy directional derivative along y-axis. dz by d alpha directional derivative along alpha axis. That is x minus y equal to 0 line. Now if this is x-axis, and then if if something is growing, contour, this is first contour that has radius 1, second contour radius, this is, if this is growing, if this is growing like this, from x axis I am seeing in this direction, then I can see the curve is growing. What rate it is growing, that is dz by dx, because contour is growing, is change in z is happening, right? That is the contour, dz by dx. If I see from here, same point, same circle, if same circle is growing, from x-axis, this is the circle. From y-axis, this is, from y-axis, if it is growing, then we are seeing in this direction, dz by dy. If there is an arbitrary line is there, that is alpha axis x minus y equal to 0, that is equation, same circle that is kept here. When it is growing, then it is seeing in this direction, perpendicular to this line. X-axis seeing in this direction, y-axis is seeing in this direction, alpha axis is seeing in this direction. So in this direction, what is the change in z? We see dz by d alpha. This is what we want to calculate. So in this direction, what is change in z I see? If I go in this direction by alpha, dz by d alpha. So change in z I see from this direction. Okay. Now I am talking about vector, because direction is coming. Can you see? So from this direction, I can see change. From this direction, I can see change in happening in this direction. In this direction, I can see change in happening in this direction. If this is I plus j vector, then I am recognizing change that is happening in this direction. If that is the case, then if I take, then what is the change I see as with respect to I plus j vector, or I plus j divided by square root of 2? I know this one. What is the change that is happening with I vector, that is dz by dx? What is the change in the contour is happening with respect to y-axis, dz by with j vector, dz by dy? What is the change that is happening along I plus j divided by square root of 2, or dz by dx minus y equal to 0 line? So in vector form, vector is nothing but, whenever we see vector, now we came to completely to vector technology. So vector technology is nothing but whatever computation you need to do, that computation is nothing but its x component computation plus y component computation plus z component computation plus all the orthogonal component computation. If you do separately and you add it, that is the effect of it. This is the vector technology. So if I say I have a vector, called I plus j divided by square root of 2, then it is combination of two vectors. One vector is I by square root of 2, another vector is j by square root of 2. So in I by square root of 2, if I do any computation, and then in the j by square root of 2, if I do any computation, if I add it, it is same as what computation I was doing along I plus j divided by square root of 2. Vector is nothing but combination of its components. Plain combination, plain addition. If I say I have a vector that is I plus j, someone would say actually vector is I and vector is j, you added it. Simple, you added it. So if addition becomes a vector of two vector, then if I have to do anything against a vector, then I'll get this vector and this vector, do the computation and add it. Then it will be against this vector. This is vector technology, inherent technology. So if I have I plus j divided by square root of 2, that is the unit vector along alpha axis, and we want dz by d alpha axis, like dz by dx axis, dz by dy axis, dz by d alpha axis, then we are trying to do dz by unit vector along alpha axis, that is I plus j divided by square root of 2. That is nothing but this x component, then there you do the computation whatever you want to do. Then this y vector, do the computation whatever you want to do, then add it. This is the vector technology. Now if this vector is I plus j divided by square root of 2, then along x-axis this vector is I by square root of 2. Here the vector is j by square root of 2. Let's do computation here. dz by di, dz by di is nothing but dz by dx. What is dz by dx? Similarly, dz by di by square root of 2 is nothing but a square root of 2 into dz by dx, because the square root of 2 is scalar value. D1 by square root of 2 into dz by dx, that is nothing but dz by di by square root of 2. Similarly, a square root 1 by square root of 2 dz by dy this. Now add it both, you get dz by I plus j divided by a square root of 2. Okay, or if I say dz by di, dz by di is dz by dx, dz by dz by dy is dz by dj, and in array in vector both components are separate, just simple addition, then it is dz by di plus j divided by square root of 2 is nothing but dz by dz by dz by I by square root of 2 plus dz by dj by square root of 2. That is nothing but dz by dx into 1 by square root of 2 plus dz by dy into 1 by square root of 2. Same thing. Okay, if that is the case, then we can say that if I want directional derivative along any axis, then convert that axis into vector, get the unit vector, and then dissociate it into x component and y component. dz by dx into x component plus dz by dy into y component of that unit vector is the directional derivative as per the vector notation. This is our proof. Then dz by dx into 1 by square root of 2, that is the ith component. dz by dy into 1 by square root of 2, that is jth component. It is same as dot product of two vector if someone see closely. That is dz by dx I plus dz by dy j, one vector, dot unit vector of that axis along which we are trying to calculate the directional derivative along, that is I by square root of 2 plus j by square root of 2. If we do dot product, it will become the same thing. So directional derivative is nothing but gradient vector into unit vector along the vector. But we can prove it by the simple fundamental of the vector also, rather than going modern way of delta x terminology. Anyway, this is what is our proof. Please support. Okay, now what is the next item that we are going to proceed in? That is partial derivative, that is Jacobian. Calculation of Jacobian. Jacobian comes into the picture when we change the coordinate system. When we do integral calculus, consider I am doing integral calculus with single variable dx, and dx I am not able to solve it. Where you are not able to solve it. 1 by a square root of a square minus x square dx is the integration. 1 by a square root of a square minus x square dx. Now integration is from one point to another point. I am not able to solve it. Then we will take another coordinate system like polar coordinate system. Let's consider x equal to a cos theta. Then it becomes simple. When we are shifting into one coordinate system to other coordinate system, or method of substitution, that is in integration, there Jacobian comes into the picture. There also we have our own invention, mind blowing. So in this picture, if I am trying to kind of what is the invention? What is the Jacobian? If I see here, dx can be written as dx by d theta into d theta. If I am changing into polar coordinate system, then dx anyway, 1 by square root of a square minus x square dx integration I can write as dx by d theta into d theta. So dx by, now I am changing into d theta, but if I want to change into d theta, then dx by d theta is coming new term, then d theta. So d theta I can write. Prior to that, I have to compute dx by d theta, then only I can convert into Jacobian. So the new term that is coming as dx by d theta is called Jacobian. If I want to convert dx into d theta, then dx is nothing but dx by d theta into d theta. I can write everything in d theta, but dx by d theta term came as new. This is called Jacobian. Like x equal to a cos theta. A is constant. Then 1 by a square root of 1 minus cos square theta. 1 by a sine theta. 1 by a sine theta. Now dx by d theta into d theta. Dx by d theta I have to calculate because that is a extra. So x equal to a cos theta, then dx by d theta is minus a sine theta. So it is 1 by a sine theta into minus a sine theta minus d theta. This is the conversion where we need first we substitute wherever I have changed the coordinate system. But d theta I cannot substitute with dx. Okay, directly I cannot substitute. In that, I mean dx I cannot just convert into d theta, or instead of dx I can say dA cos theta. Someone can say just put a dx, right? So dx instead of x write a cos theta, then it becomes minus a sine theta d theta. All right, but we will see in multivariable calculus that is not that straightforward. Consider whatever dx by d theta is extra thing that is called Jacobian. Based upon it, we will change the integral limit also. So Jacobian comes into the picture. Like every integration has limit, integrand and differential. The differential part when we change into another coordinate system, and whatever extra thing that is attached in the kind of award that we are getting while changing the coordinate, that is called Jacobian. So this is called full Jacobian. Or I have a 1 by a square root of a square minus x square minus y square dx dy, that is the integration dx dy. If I go with polar coordinate system, then it is x equal to r cos theta. Now it is multivariable, that two independent component I have to take. X equal to r cos theta, y equal to r sin theta. In that case, it will become 1 by a square minus r square cos theta minus r square sin theta. 1 by a square minus r square root into now anyone can change me in now x equal to r cos theta, d r cos theta and dr sin theta. Now there are two independent components r and cos theta. D of r cos theta will come to nothing, so we need Jacobian now. So how I can change dx dy into d theta dr? So if I say dx dy is xy plane, dxy plane, then I can write dxy plane is nothing but dxy by d theta r into d theta r. So d theta r numerator becomes d theta dr. Dxy by d theta r plane will become is Jacobian. Now that is the extra thing I have to calculate dxy plane by d theta r plane. This is called full Jacobian. There is something called cross Jacobian. This is our invention. Cross Jacobian, you search anywhere in the book, it is not possible to search. Like directional derivative along any axis or any vector, first convert it to vector, and then take the x component and y component, calculate the directional derivative along x and y, simply add it, because this is the inherent nature of vector. If you want to do any vector manipulation, then simply do it in its orthogonal component side and simply add it. This is the inherent nature of vector. Similarly, now if I'm going with the change in coordinate, then dxy I can write dxy by d theta r into d theta r. Now dxy by d theta r is called full Jacobian. What is cross Jacobian? So cross Jacobian we will use while calculating the surface area of a sphere. Okay, then anyone would understand the cross Jacobian. What is surface area of a sphere? Now we consider this as a sphere back. Consider this is a sphere back. This is a sphere. What is the full surface area of the sphere? This is xy plane and blue dot is the origin. Now this is centered at the origin. So half the way it is pierced and it is centered at the origin. If it is centered at the origin, then what is the full surface area of this sphere? How someone can calculate full surface area of this sphere? Okay, now what we see in the calculus, there are independent component, dependent component. What is independent component here? X-axis and Y-axis is independent component. What is dependent component? Z-axis is dependent component. Now, if I take any point on the surface and I say this in point is P, then what is the coordinate of this point? X comma Y comma Z. X comma Y comma Z. That is the point of that any point there. Now, against that, I believe people would understand. Now, against that point, against that point on the sphere, against that point, I have a point, I have a point on the xy plane, that is x comma y. This x comma y go up and hit a point on the surface. That point is P. The coordinate of P is x comma y comma z, for which the point on xy plane is x comma y. If I move delta x, if I move, this is the new calculus. If I move delta x along x axis, what is the new point? If this is P, the new point is P1. That is x plus delta x comma y plus new z, because z is dependent upon x and y. Z I can say function over x and y. So first point on the sphere is x comma y comma fx comma y, function over x comma y. If I move delta x along x-axis and go up and hit another point, that is P1, then coordinate of P1 is x plus delta x comma y plus f x plus delta x comma y. If I subtract these 2 points, then it will become a vector. One point and other point. If I subtract these 2 points, this becomes a vector, because vector, if I want vector between these 2 points, coordinate, if I subtract these two coordinates, whatever comes is the actual vector notation I can represent in. Then vector is delta xi, y gone, delta xi plus fx plus delta x comma y minus fx comma y j y k. This is one vector. Understandable, right? So if I have any point x comma y, it go up on the biggest sphere I was showing, it is hitting a point called P. Now coordinate of that P is x comma y comma z, or x comma y comma fxy. Now from x comma y, I move little bit in x direction, x plus delta x comma y. If I go up and it hits another point on the sphere, another point is P1, P1. If I connect these 2 points, it becomes a vector. Call it vector A. Call it vector A. Then vector A is nothing but subtracting these 2 points. That is x plus delta x minus x, that is delta xi plus y gone plus fx plus delta x comma y minus fxyk. This is vector A. Similarly, if I move in y direction, delta y, not in x direction, the new point in xy plane is x comma y plus delta y. If I go up and from point P, if I draw a line over there, then it becomes delta yj plus fx comma y plus delta y minus fxy k. So one vector is A vector, one is vector B vector. If I do cross product of these two vectors, then I get the surface area. If you see very closely, at any point on the sphere, if I see 2 points, 2 point on the 2 point on the sphere, one is x comma y and x comma y comma z, and other point is x plus delta x comma y and new z, and another point. So this vector, if I take another vector, if I do cross product, I get the surface area of the sphere at that point. Okay, everything behind the scene is algebra. This is vector algebra, algebraic vector. So it should be all right. What is the vector? What is the surface area? If one vector is A vector, another is B vector, then A cross B. What is A vector? A vector is delta xi plus fx plus delta x comma y minus fx comma y k. This is A vector cross B vector. Understandable, right? Delta yj plus fx comma y plus delta y minus fxy k. So A cross B is the surface area. Now A cross B, I divide it by delta x into delta y. Just I divide it. If I divide, then I have to multiply also. This is modern way of proving getting the surface area. So A cross B or point P1 to P, one vector, and P to P2, P to P2, another vector. A cross B is the surface area at that moment on the sphere. If that is the case, then dp by then A cross B is the surface area. I divide it by delta x into delta y. Accordingly, I multiply it by delta x into delta y. So I mean I can multiply this A cross B with delta x into delta y by delta x into delta y. So now it becomes A cross B by delta x into delta y into delta x into delta y. Now what is a vector? That is delta x I plus fx x plus delta x comma y minus fx comma y k divided by delta x cross cross f cross cross delta yj. I believe if I say I have sent just j, delta yj plus f x comma y plus delta y minus fx yk divided by delta y. Now if we see this, then if I divide it by delta x, then it becomes I plus fx plus delta x comma y minus fxy divided by delta x k. Fx plus delta x comma y minus fxy divided by delta x is nothing but dfxy by dx. Okay. Similarly, that side it will become j plus dfxy by dy k. That is nothing but I plus dz by dx k cross j plus dz by dy k. Now, what is I plus dz by dx k? If I take any position vector p whose coordinate is xi, this is our proof. Any point if I take, this is not available anywhere. We will have other proof also, but this is also our proof. Please do support us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number. Now, now what I did is A cross B vector, A vector cross B vector is a surface area. I divided it by delta x, delta y, multiplied it by delta x, delta y. A vector is delta xi plus fx plus delta x comma y minus fxy k divided by delta x cross B vector, that is fx comma y plus delta y minus fxy minus fxy k divided by delta y. The first, if I settle down, delta xi plus fx plus delta x comma y minus fxy k by delta x cross product delta yj plus fx comma y plus delta y minus fxy by delta yk. Okay, if I do it, then first becomes I, simple I plus fx plus delta x comma y minus fxy divided by delta x k cross j, delta y j by delta y is j, delta y del j plus fx comma y plus delta y minus fxy by delta y k. Now, first term, that is I plus fx plus delta x comma y minus fxy by delta x is nothing but dfxy by dx. K. My cross product j plus fx comma y plus delta y by minus fxy by delta y is dfxy by dy. K. Okay. Now, this is cross product of two vector. One is I plus dz, fxy is z, dz by dx, k cross j plus dz by dy, k. Okay, if that is the case, then now consider the point, the P point I had taken that had coordinate x comma y comma fxy. If I say dp by dx, exactly it becomes I plus dz by dx k. If If I do dp by dy, then exactly it becomes j plus dz by dyk. Same. Then it looks like this cross product turned up into dp by dx cross dp by dy. dp by dx cross dp by dy. It is nothing but d surface area by dxy plane. dp by dx cross dp by dy is nothing but d surface area by dxy plane. Okay, so d surface area by dxy plane into delta x into delta y. I can rewrite as dx dy. This is the net computation to compute the surface area. dp d dp by dx cross dp by dy or d surface area by dxy plane. P denotes the position. So dp by dx cross dp by dy is nothing but we have shown it a vector cross b vector divided by delta x delta y. That is dxy plane. So we can say d surface area by dxy plane into dxy plane. So this is called the computation of surface area. Now if someone does it, then he is open to do it. That is nothing but I plus dz by dx k cross j plus dz by dy k. If someone does this cross, it becomes minus dz by dx I minus dz by dy j plus k. If I compute the magnitude of this, because at the end we are trying to calculate the surface area. So this vector will calculate the magnitude. Then it becomes dz by dx whole square plus dz by dy whole square plus 1 square root dx dy. Now if someone compute this integration, then he would get the surface area of a sphere. Okay, we will proceed into it and we will see what is the problem that we are seeing calculation of surface area. dz by dx, z equal to square root of a square minus x square minus y square. dz by dx is minus x by square root of a square minus x square minus y square. Okay, dz by dx. So dz by dx whole square is nothing but x square by divided by a square minus x square minus y square plus y square divided by a square minus x square minus y square plus 1 whole square root. If I settle it down, it becomes a by a square root of a square minus x square minus y square dx dy. If someone calculates it, then he gets the surface area of the calculation of the surface area of the sphere. Very tedious, right? A by square root of a square minus x square minus y square dx dy. Then someone would use spherical coordinate system, cylindrical coordinate system, like this kind of coordinate or polar coordinate system to compute it. If I take polar coordinate system dx dy into theta r, then dx dy is dxy plane. I can write dxy plane by d theta r into d theta r. This becomes Jacobian now dxy by d theta r and then d theta dr. Now I have to substitute this a by square root of a square minus x square minus y square in polar and calculate the net it. This is full Jacobian. What about cross Jacobian? That we will see. Please do support us.